when we learn about gas law, you should understand about kinetic theory of gas. So the name tells you lah, kinetic theory. What do we mean by kinetic? Okay, when we talk about kinetic, what come across to your mind? It's about movement kan? Okay, ada moving objects ataupun moving substance ke ataupun moving particles. Okay, so it's about movement. Okay, and then you have watched the simulation. You should be able to describe movement of gas molecules. So what is the movement? The movement is, you can say, if you want to describe them, what should be, what can be your answer? Type your answer. Check.
Random.
Tu dia, random kan, random. And how about the space filled by gas molecules? Okay, then you see the space, dia almost fill up the whole region tu kan. Okay, and then you can say they are far apart from each other. Okay, and then can you tell which direction? No, you cannot. Did you notice collisions between gas molecules and the walls? Okay, and then if you watch the video, watch the simulation, you will notice this one. Okay, and this is the important part ni. Okay, so in this topic, okay, we have 3 important physical quantities, okay, which you have answered during watching the video. Okay, collision between gas and walls produces, lengkapkan jawab soalan ayat tu.
Force.
Produce
Pressure.
Very good. Okay, I heard that. First ada yang kata force. Great, very good. And that force produces pressure. Okay. Alright. Okay, so you have to look at this. Okay, how they are related to each other. Okay, and then we have these units, right? And what we want to, okay, you will answer questions after this. Okay, relationship between pressure and volume. So you know that, okay, we have pressure, volume and temperature. But here, temperature is not mentioned. Why? Because in order to, yes, okay, very good. Thank you very much. We want to see the relationship between 2 physical quantities. So these are the 2 physical quantities, pressure and volume. Therefore, another physical quantity must be constant. Okay. Now, so this is the experiment you must do. Nanti insyaAllah kita buat. Okay, you have watched the video simulation. Kalau buat eksperimen, of course you will record your data. Okay, and then you will get a graph. Now tell me, if you have graph of pressure against volume, can someone tell me now what is the relationship between the pressure and volume? Let's ask. Okay, before I call, sebelum saya panggil nama dah ada orang respond. Very good. The answer is inversely proportional. Can someone draw on the screen? So this is the shape of the graph. So this graph is inversely proportional. Now, this is when we have graph of P against V. Okay, so that's the shape of the graph. Now, the same experiment, okay, however, we want to plot pressure against 1/V. Okay, as how is the graph look like now?
Straight, directly proportional.
Sarah, are you here, Tengku? Sarah?
Yes.
Tengku, Sarah?
Yes, teacher. Yes, teacher.
Directly proportional. So, The graph is straight line graph. Now, why are they different? Okay, because this one is 1 over V. Okay, so the way we write pressure is, okay, listen carefully. We say the way we write here is directly proportional to 1 over volume. That's how you say. Okay, kalau awak nampak ni, if you look at these symbols, okay, this is pressure is directly proportional to 1 over volume. Or the same symbols, you can write it as pressure is inversely proportional to volume. Pressure is inversely proportional to the volume. Okay, Boyle's law. For a fixed mass, you mesti first mention about, okay, for a mixed plug. For a fixed mass of gas, pressure is inversely proportional to the volume of gas lah. Okay, but that is not complete yet. Okay, first you must have fixed mass. Kita nak bagi tahu mass also constant. Next, you want to tell pressure inversely proportional to the volume. Another important point is you kena mention at constant temperature. Barulah lengkap your definition ataupun the statement of Boyle's law awak. Okay, ada 3 points kat sini. Okay, 1, 2, 3. So this is in one sentence. So knowing that, kita dapat this relationship. Okay, from that relationship, you have learned in mathematics, P directly proportional to 1 over V. Therefore, if we want to change the equation, we have to add K as a constant. So from there, we can get K equals to PV. So that's the formula we get. So if we have two conditions, we have P1 V1 equals to P2 V2. So knowing this, it will help you to solve problems. Okay, if you are asked to solve problems. So this is the example problem. Okay, now
Guna formula.
air in a closed syringe has a volume of, so guna formula. Okay, now, okay, and then when you have read the question, then you need to list the given information. Itu penting, tapi ramai student takkan buat tu. Okay, tapi student yang nak dapat A star, please do as what I asked you to do. So first, you list down apa dulu yang kita ada. A closed syringe has a volume. Okay, so we have V1 there. Okay, and then kita ada apa? And pressure 108 kilopascal. So that is the respective pressure. The piston of the syringe is pushed to compress the air to volume of, okay, now this is the new volume V2. So Alan nak apa? Calculate the pressure of the compressed air. After second condition be done, so you have to calculate pressure. So what's the formula?
P1 V1 equals to P2 V2.
Okay, thank you. P1 V1 equals to P2 V2. And then what we need to do? Okay, satu markah. Then what you need to do?
Masukkan value.
Substitute.
Masukkan value. Substitute. Excellent. Okay. Itu yang awak kena buat. Okay. So, what's V1? 60 centimeter cubic equals to, do you have P2? Itulah yang kita nak kan?
Rearrange.
So P2 is 48 centimeter cubic. So you just rearrange now and you get the answer. What's the answer? You calculate lah, guna calculator. Please help me calculate. What's the answer there?
135.
135. Ada unit tak?
Kilopascal.
Kilopascal. Yes. You cancel out centimeter cubic. So tinggal tu. That is why it's good if you write the formula, the units as well. So that at the end you know the final answer you must include the unit. Okay. Okay. Question number 1. Answer is
D. Determine.
Okay, Antasha said determine. What about the rest of you? Do you agree? Are you okay? Okay, the question is very easy. The gas is sealed. Okay. And constant temperature. So, if temperature is constant, so PV, so that is Boyle's law. Okay, so Boyle's law statements, Boyle's law kata apa tadi? Boyle's law, pressure is inversely proportional to volume. So this is the answer. Okay, well done. Okay, a closed container of gas is heated, the pressure of the gas increases. Which statement explains this increase in pressure?
C. C.
Okay, somebody vote for C. Confident.
C.
Okay, 2 students answered C. Okay,
C.
now, what about C or D?
D.
Okay, heated. The gas is heated. The pressure of the gas increases. Okay, pressure increases. Which statement explains this increase in pressure? Why the pressure increases?
A.
What makes the pressure increases? Is it because of the collision with each other?
No.
No. That's
Collision with wall.
Earlier, just now, yes, the pressure is caused by the collision with wall. There will be more collision, but that does not cause pressure. So be careful. Ramai student akan silap ni. Okay, and then let's look at A. The changes in the momentum of the gas molecule striking the walls of the container increases. Is that correct?
Yes.
Okay, striking the walls of container increases. Okay, betul tak? Okay, that is correct. So that produces momentum. So changes of momentum, molecules strike the walls. Okay, so you need to recall back what you have learned. Remember formula momentum, P equals to mv. Okay, and then here it says Not only momentum, it mentions here changes in momentum. So changes in momentum is what? Ada perubahan lah. Momentum sebelum dan momentum selepas. So that's why I wrote there minus. So that is change of momentum. Okay. And you must know that change of momentum is related to impulse. Okay. And then impulse, we have impulsive force. So this is impulse. That is, okay, tulis ni take note. Okay, right, add this one in your notebook because this one is not in the video. Okay, that's why lah saya buat video supaya saya boleh cerita benda lain. Therefore, from this equation, okay, mana equation yang mana ni? From this equation here, so this one is tadi equal to change of momentum tadi. Okay, right. So from that equation, we can have rate of change of momentum. And if you look at this here, so this is F. What is this F? This is impulsive force. Hopefully you still remember about this one. Okay, so this is what we trying to say. So the answer is A, correct. Okay. Okay, very good, well done Syabil Aiman, very confident. Syabil kata A. Okay, good. Who is Syabil? I cannot recall lah which one is Syabil. Okay, Syabil. Tunjuk muka sikit Syabil. Suka nak tengok ni budak-budak ni. Okay, tak apa. Okay, number 3. The metal lid on a glass jar is difficult to unscrew. Have you ever experienced this situation? Do you understand the situation?
Yes.
Okay. Yes. Read further the question. The jar is placed in a warm oven until the jar and the lid reach the same temperature. Okay, this is revision topic, thermal equilibrium and also process apa nama dia? Which topic? Transfer of heat. The lid is now easily unscrewed. Which property accounts for this? Why is it? Why after you put the glass jar in a warm oven, why after that it is easily unscrewed? Before that it was difficult. So what happened? What
Expand.
Other expansion. Very good. Well done.
Thermal expansion.
Yes, that's the answer. Okay. 3 is the answer is D. It's because of thermal expansion. Conduction pun ada. Tak ada this one sebab its user kenapa tak boleh thermal conduction? Why cannot answer thermal conduction? Because we use oven. You know what is an oven is, right? So if this is an
Radiation.
oven, yeah. So this one, this only use radiation process. Who said just now? Okay, well done. Okay, excellent. So radiation, not conduction. There is no contact between the oven and the heater lah, the heating element, not the oven. The heating element is not in contact with the jar. So it's radiation. Therefore, we cannot answer conduction. Okay. Alamak, ada tersilap ni. Now, number 4. A bubble of air has a volume of 2 cm cubic at the bottom of a lake where the total pressure is 4 times 10 to the power of 5 Pascal. The temperature of the water in the lake is constant. The atmospheric pressure at the surface is 1 times 10 to the power of 5 Pascal. Can you imagine the situation? So this is a lake. Saya buat side view. So this is a lake. So the air bubble, A bubble air has a volume of 2 at the bottom. So this is at the bottom. The volume 1 is 2 centimeter cubic at the bottom. Okay, and the total pressure is 4 times 10 to the power of 5 Pascal. The temperature is constant. Atmospheric pressure at the surface. So here, at the surface here, pressure 2 is 1 times 10 to the power of 5 Pascal. So what's the volume here? Agak-agaknya the volume here. What's the volume? So that
2
it should be our
centimeter
V2. Yeah. So that's the question. What's the answer again, my dear? Siapa jawab tadi? Aina. Dapat tak jawapan? What you need to do to answer this question?
V1 times P1.
Yeah, okay. So you will use formula P1 V1 equals to P2 V2 and solve the problems. So what's the answer?
D, determine.
Do you get the answer? Yes, the answer is D, determine. Well done. You just plug in the numbers and use this equation. Discuss question number 6. Okay, state 3 factors that determine the rate of evaporation of water. This is again another revision question. That determine the rate of evaporation. Do you still remember?
Temperature.
What's the first?
Humidity.
Temperature.
Excellent. Temperature.
Surface area.
Humidity. And
Surface area.
surface area. Yay. Okay. 3 marks. Easy peasy. Okay. Right. Fantastic. A person, number 6B, a person climbs out a swimming pool and stands in the open air. Okay, you just imagine lah, you pergi swimming pool and then you climbs out from the swimming pool. Explain why evaporation of water from the surface causes the person to feel cold. Okay, how do you explain this one?
Specific latent heat.
Evaporation.
Because the high kinetic energy particles escape, leaving the low energy particle.
Very good. Okay, that is superb. Siapa tu? Okay,
Saya.
well done. Saya, bagus saya. Okay, Antasha. Okay, so more energy. You need to know okay, the way you answer. Okay, this one saya dah explain di dalam the video hari tu. Okay, again, I explain again. So we have lots of molecules of water. And then you need to know every molecule has its own energy. But the more energetic molecules, what happened to it? What happened to them?
Escape.
Will escape. Why? Because they have more energy. More energetic molecules escape. Then what happened? 2 marks. Then what happened? tak menjawab lagi kenapa sejuk. So, siapa yang tinggal?
Ada
Now, yang more
tinggal
energetic
low
dah pergi.
energy.
So, what is
energy.
left? Ya, yang tinggal
Low
what is
energy
left?
molecules.
Ni pun ada energy juga. Kan? This one pun ada energy. But they have lower energy. So you say less energetic. Tadi more, now less energetic molecule. What happened to the less energetic molecules? Remain. They stay in the beaker. Dia tak pergi mana-mana. Jadi, what happened?
Temperature decrease.
Okay. So, you can say thermal energy flows from body. Kan? Okay, thermal energy of body is less lah. Okay, so or you can see just now somebody mentioned about evaporation. I hope you jot this down ya. Kalau keluar dalam final ke in mock IGCSE, you know what to answer. Requires latent heat of vaporization. Okay, right. So that's how you answer. Okay, kita akan ambil lah mana-mana jawapan yang betul. So this one, okay, betul. So maximum 2 marks.